Welcome to the Graphing Systems of Equations review. As you can tell from this first problem, when we graph systems, we want to have y by itself. Because if you have y by itself, then you have a starting point and you have directions on where to go from there. Now, because I don't want to make a graph, you'll be provided with a graph anytime you're asked these questions. So I know there's some marks here, but we're going to ignore those. We're going to look at graphing the first equation. So when I look at the first equation, I see this -4. That tells me that when x is 0 here, this whole thing disappears. I still have -4 for a value. So I'm going to find -4 on my y-axis. Here's the center, -1, -2, -3. Here's -4. So I've got my starting point. And then I look at the slope to figure out what I'm going to do next. When I look at my slope here, I see that I'm supposed to go down 5 and to the right 3. But going down 5 and right 3 isn't going to fit on most of the graphs I give you. So 1, 2, 3, 4, 5, and then to the right 3, 1, 2, 3. I can put a point here because my graph is really big. But you also could have gone up 5, 1, 2, 3, 4, 5, and left 3. Notice if you do that, it's kind of like the same road. So one of them would be going from Gardner to Augusta. The other would be going from Augusta to Gardner, but it's the same road. So I'm allowed to go down and to the right or up and to the left. Both of those are describing the same line. Now I can go to my second line. If I look at the second line down here, it only has one variable in it. So I know it's a special line. I know that it's either going to be a horizontal or a vertical line. It's going to be one of those two. So I'm going to find the value 1 on the y-axis. Here's 1 on the y-axis. And I'm going to know that no matter what the x value is, y is always at a height of 1. So that's the line that I get when I say y equals 1. And this is the line that I get when I say y equals -5 thirds x minus 4. And I can see from my graph that they intersect at this coordinate point, which is left of the center by 3, and then up 1. So I have my solution of -3, 1. Now we're going to go to the more challenging example. This one's more challenging because I don't know what y is in either example. So when I try to get a starting point, I don't really have one. I can't say that this graph starts at -2 because I don't have y by itself yet. So I've got two different problems I've got to do. First, I need to get y by itself. Then I need to worry about how to graph. So if I look at just this first problem, and I want to give myself a little space to write, what I have to do is get rid of this 3x term. But I want the whole thing to go to the other side. So I'm just going to use minus to move it around. The only time you want to be using division is when you're trying to separate a number from a letter. So if I wanted to get rid of just the 3, then I'd be using division. But I want to get rid of the entire thing, so I'm going to use subtraction to do it. Notice I've just written it in the form I want. I want my lines always to look like this, y equals x and a number. Now I have y equals x and a number. So this line's ready to graph. The second line here has an extra step involved. I'm going to get rid of my 2x the same way that I got rid of the 3x, by doing -2x. What makes this problem a little different is I still have a negative in front of this y. Since that negative is there, now I need to use division because I'm trying to get rid of this negative. I'm not trying to get rid of the y. So I need division to split that negative off. Division is going to get rid of just the negative, and it's going to leave the y on the left side of the equation where I want it. The negative over a negative is a positive. I can leave the 1 there because I know I'm going to be graphing. And then -3 divided by -1, it's a +3. Now I have both lines that I need in order to make my graph. So if I come back to my graph, which I've blanked out conveniently, what I'm going to do is start with my blue line here. It starts at +3 on the y-axis. That's my starting point. From there, it says 2/1. If things are looking up and going the right way, that's positive. Those are both good things in our life. So I'm looking to go up and to the right. Going up 2, right 1. Up 2, right 1. Up 2, right 1. Now, same road is down to left 1. So I'll fill out the rest of that just in case, because I don't know where these lines are going to intersect. I'm just guessing at it right now. Now that I've graphed this line, I can go back to graphing this line. -3x minus 2. So in order to do that, I'm going to start at -2. And then it just says -3. How about I make a fraction out of that so that I can interpret it a little better? Down 3 to the right 1. 1, 2, 3, 1. 1, 2, 3, 1. It's certainly not going to intersect on that side of the line. But if instead I go up and to the left, I'm going to have a nice intersection point right there. 1, 2, 3, 1. So I've got this line, and I have my other line. But they're both intersecting at this particular point. That particular point is left 1, up 1 from the center. So I know the solution to my system is -1, 1. And that's how you graph a system of equations to get a solution. Wherever it intersects, that's the answer. I'll step aside so you can see the work. Good luck.